Hi there, my name is Ron Rogers, and this presentation is titled Flight Test Tales Cessna Wallace in the 80s. Take off 1,000 pounds over maximum takeoff gross weight and the Scenic Airlines crash. Now, those of you who are familiar with this aircraft will recognize this as the Cessna 404 Titan. It's a really great aircraft. It could really carry a lot of weight. It had a useful load of 2,765 pounds and a maximum takeoff weight of 8,400 pounds. 396 of these aircraft were built, and this was one of my early test issues with Cessna Wallace test flights that we went out on. And the first thing we're going to do in regards to this was we were going to get some performance data on taking off at 1,000 pounds over maximum gross weight for this aircraft. They were looking at developing the Cessna 406. They called it the Caravan 2, and it uses PT6A turboprop engines. And they wanted to see if the extra gross weight, they were going to use the 404 airframe, just put more powerful engines on it. And they wanted to see if the extra gross weight would affect the stall performance and various other slow fight characteristics like that. So the 404 that we were using was one of the Cessna flight test aircraft, and we used it as a water tanker. It had a spray bar up on the tail, and unfortunately I don't have a picture of it, but it had a spray bar up in the tail, and we had load it up with water and operate pumps that would spray out water, and you could fly a test aircraft behind it to produce icing. So we could get icing tests using this aircraft as a water tanker. Well, because it had a big tank full of water, we could load that up, and we loaded up 1,000 pounds over the maximum gross weight. And there was a little handle where we could dump the weight quickly, because you don't want to take off 1,000 pounds over gross weight. You lose an engine and you're in deep trouble. And actually, the performance people and the structural people cleared us for the flight, but it was a heavy aircraft. The 406, it was more expensive to operate than the single engine Caravan, which was another aircraft developed at that time. But they needed this in Europe because they needed two engines to comply with European regulations regarding commercial operations, which only allow multi-engine aircraft for commercial instrument flight. They only built 99 of these aircraft, but our mission was to get data on a heavyweight performance of this airframe. So here's a view of Wichita Mid-Continent, where Cessna Wallace is at in the lower right-hand corner there. And we taxied out from that location over to 19 right. And those familiar with the 404, it's got that trailing link gear. And with the extra weight, that thing really kind of wallowed on taxi. And we go over here to 19 right. We get cleared for takeoff, and we begin our roll. And we roll. And we roll. The acceleration was slow. I've got my hand on this handle the entire time, because if an engine so much as coughs, that water is gone, and we lose the gross weight. We used nearly the entire runway to get airborne. And Tower actually asked us, "Is everything all right?" They were used to flight test aircraft doing weird things, but they were concerned. We go, "Yeah, everything's fine." The climb rate was very slow, but we got it up to altitude. We did the various tests, got them the data, got them the performance information they needed, and they developed the Cessna 406, the Caravan 2. Now, single engine performance in propeller airplanes is kind of an interesting aspect, especially for a guy who was an Air Force pilot, because you fly high performance aircraft, you got tons of power. And I had a short stint where I was flying the O2, and I was very concerned about that because I knew a lot of pilots who were in the F4, and they went to forward air control or positions in the O2. They lost an engine and they were killed. So I'm kind of concerned about the performance on this aircraft, because I knew it wasn't fantastic. Now you take your typical fighter. You lose an engine, that's not even an emergency procedure. It's thrust as necessary in the F-15. At least it was way back 40 years ago. I don't know if it's changed, but back then it was just thrust as necessary because you got a lot of power. O2, not so much. Now, I was getting my ATP. I was going to become an airline pilot. They were going to put me in a ground job as my next assignment, and I go, no, I don't want that. I'm going to fly. I'm going to fly. So I got an airline job, but I'm getting my ATP, and we're using an Apache. It had a drum directional gyro that you could actually watch it process. They were going to get that fixed, never did. Took my check ride with the FAA with the thing continually processing, and we do one of the first takeoffs in this. 160 horsepower each side, no accumulators for feather or unfeathering. So we take off, get 100 feet. The instructor pulls the engine back to zero thrust, and we're driving at 100 feet. And I said, well, when does it start to climb? And he says, it doesn't. This is as good as it gets. Well, that's when I found out that any piston civilian aircraft certified gross weight less than 6,000 pounds does not have to demonstrate positive climb rate, single engine. Fortunately, my turbo Cessna 310R is above 6,000 pounds, and it will generate positive rate of climb on one engine. Although I've gone out and done some flight test stuff, and I can't quite duplicate the book numbers, which kind of concerns me. I may have to play with that a little more. So now I'm coming off the 38, and I'm getting my ATP in the Apache. Now the 38, you lose an engine, heavyweight, or that's maximum takeoff gross weight for the T-38. You just take off. One of the things I did as an instructor is when I gave a check ride, we took off. We simulated single engine heavyweight. We came back around for a single engine pattern, and we flew that to a go around. Well, you still got a climb rate of 4,000 feet per minute single engine, so you're not really hurting. Remember this guy? Nothing. In fact, he later told me that he was a little surprised we were even maintaining level flight because we're out in the Fox Valley. It's high, not terribly. I mean, 2,300 foot field elevation, but it's always hot out there. So he was actually surprised the aircraft was even climbing, and we're doing good just to maintain level flight. Now, the other situation I want to talk about is the Scenic Airlines crash. We, under the direction of NTSB, had to acquire some data. And July 21st, 1980, a Scenic Airlines, it was flight number 306, a Cessna 404 VF commuter flight from the Grand Canyon National Park Airport was going to fly to Phoenix. And the pilot and 6 of the 7 passengers were killed in the accident. 1 passenger survived and died 5 days later. The accident was actually, from forces, survivable. Everybody died of the post-impact fire, unfortunately. And the keywords on this was takeoff engine malfunction. The left engine failed. High density altitude. The density altitude was 10,000 feet. The marginal single engine performance, windmilling propeller, and there were some aircraft maintenance issues and pilot training. The impact forces were survivable, and the post-accident fire is what killed him. Now, this is the airport, and it's at high elevation, 6,609 there, and with the density altitude that day, it was 10,000 feet. The aircraft was at 7,500 pounds takeoff weight, and the maximum takeoff weight is 8,400 pounds. So they had 900 pounds to spare. But, and the thing I have to give credit for the airline, they actually weighed the passengers. In the airlines, they just assume everybody's 180 pounds, right? Yeah, that works. But they actually weighed the passengers. Now, according to the flight manual, the best single engine rate of climb under these conditions was about 160 feet per minute at the VYSE. That's best rate single engine. And the VYSE speed is 99 knots. Now, this assumes that the landing gears were tracted, the wing flaps are up, the inoperative engine feathered, and that was one of the problems. He didn't feather it. A 5-degree angle of bank into the operative engine. We call this the raising the dead thing. And half ball with slip deflection on the turn in bank indicator. Now, what they wanted us to find out is how much angle of bank affected all of these characteristics. Now, in spite of the very minimal climb performance, and while I was doing these test maneuvers, we had a Cessna 404. It had a brand new engine on the right side. They leaked checked the intake and exhaust system to make sure everything was perfect. And so we had a perfectly operating new engine, and we were going out to get some data. And 160 feet per minute, if you've ever played with that, driving along at close to 120 miles per hour, that you're going 2 miles a minute, and you're only climbing 160 feet in that. Yeah, that is not impressive at all. But they wanted us to get some data, and the data was actually quite interesting. Okay, you're going to bank 5 degrees into the operative engine. Well, what if your bank is 0? Well, you lose 20 to 30 feet per minute, less than the published. So 160, take off 20 or 30 feet per minute. Well, that's not going to, and I hate to use the word kill you, but it's not going to kill you. You're still going to be able to have a decent climb rate. Now, let's do the other thing. If you bank 5 degrees towards the inoperative engine, the climb rate is killed from 100 to 150 feet per minute. 5 degrees of bank the wrong direction, and you can lose your entire climb rate. Now, another interesting thing about this, that the VSYE, the single engine best rate of climb speed, is less than the minimum controlled speed for this situation. So you're gonna depart the aircraft if you try to get your best VYSE speed. Now, we also did data. If you bank 10 degrees towards the operating engine, the climb rate is 150 to 200 feet per minute. So that is really going to do you in there. You've not only lost all your climb rate, but you're going down. And we didn't even look at going into the inoperative engine, because given what you got at 5 degrees, it was going to be just really bad. So that's the NTSB report, and it was an eye opener for me, being a military pilot. And they cited training issues in this report, that the people weren't given adequate training on single engine performance, and of course you're operating out of high altitude, hot airports. With high density altitudes, you really need to have everything perfect. And unfortunately, that day they didn't, and the people died because of it. Anyway, thanks for watching.